Hello, everyone. Welcome to this webinar about the essentials of React Server Component. My name is Jan-Niklas, and today I'm here with my colleague, Christian. Christian, do you want to say a couple words about yourself?
Of course. Hi, everyone. I'm Christian from the WebStorm team at JetBrains. I used to be a teacher and lecturer at university. Eventually, I ended up in software engineering as a full stack engineer, doing a lot of work with React. And nowadays, I'm working at JetBrains to work on the tools that I use myself at work. And I'm really eager to show you what React has in store for us, especially after all the changes that we've witnessed in the past decade almost. And I'm really curious to see where we end up in the next few years.
Great. Thanks a lot for joining us today. I really appreciate you taking the time to teach me a little bit about React and this whole server component things. As it's still very early, I hope every one of you grabbed a cup of coffee, is very comfy in a chair or something, and enjoys today's webinar. Let's go over a couple of rules just to set that straight. If you have any questions, feel free to use the chat. If you don't have any questions, feel free to use the chat. If you just want to be social, feel free to use the chat. Just type in your question, and we have a couple dedicated blocks throughout the webinar where we will go to your questions, so we'll come back to them later. Or also a couple of my colleagues are in the chat apparently, so they might pick up some of the questions as well. Before someone asks, yes, this webinar is recorded. I mean, it's on YouTube, so it will be announced as well afterwards once the link is available. But on YouTube, on the JetBrains TV channel, you will find all the links to the video and also other good content, so might consider checking that out. We come to that later. I shouldn't have showed that, but in case you're interested about more stuff later on, here's some links. And having all this organizational stuff said and out of the way, Christian, you want to take it over from here?
Of course. Thanks. All right, everyone. Before we actually start with the live coding session that I've promised you for today, we have to go over a few things about terminology, because I've seen that in the past few years, a lot of misconceptions have come up and misunderstandings. For that, I've prepared a small infographic here. So for today, we will be talking about these React Server components that you can see in the middle. However, people have been working with Next in particular, using the app router that is part of Next.js, and have been misunderstanding and thinking that everything is the same, which is unfortunately not the case. So React Server components are a new key component within the entire React ecosystem. And Next, as a framework, just happened to be the first big framework around that actually supports the server components. They used to have the Pages router, which will be still supported in the next few major versions. So all the applications that you have maybe written using Next and the Pages router will still be working. However, they introduced the app router, which had a bunch of Next-specific quality of life improvements, but also the support for server components. So in this case, it's just a completely optional feature. If you want to use server components, you can just opt in, but you don't necessarily have to. And in a similar fashion, people have been using asynchronous components, but that doesn't necessarily mean they have to be server components. In general, the terms Next.js, app router, server components, and async components just happen to be completely independent technologies that you can as well use completely independently. It just so happens that right now everything works together quite well. And what we're looking for in the future is that other frameworks such as Remix, for example, add support for React Server components themselves so that you can mix and match whatever suits best for your own application that you're developing. So that's probably one of the most important things that I wanted to mention today. Is just everything here is completely independent from one another. But for today, we will be using everything at once. And I will be showing you first what we will be developing today. So as a context here, I'm a big fan of Magic the Gathering, which is a trading card game. Behind me in my closet, I have like 100,000 cards or so, which I use to play with, and on competitive events, I trade and share cards. And for that, I need a database. I want to keep track of which cards I already own and how many copies of each card I own. And here you can see just a simple application that loads a few of these cards from a database. We can then, for example, filter these cards using their names, for example, filtering for my favorite mage, Teferi, or for example, searching other cards like Chandra, or maybe if you're more into Dungeons and Dragons, finding some class cards. And for each of these cards, you can see that there are buttons on the right-hand side. And if on the Sorcerer class card, for example, I press the plus button, I can see that the amount of the copies that I own increments automatically. And if I press on the minus button down here, it decrements. And this is just persistent in my database. And this is what we will be building from scratch today in a few bigger steps. The first step will be fetching cards in general and then displaying them. That's the first block. Then we'll be moving on to the second block by adding the filtering of cards with the search bar here at the top. That's the second part. And finally, we'll be implementing the mutation of data on the server side using so-called server actions in order to keep track of how many copies of these cards I own. And all of this will be actually done with server components and the features that accompany server components as much as possible. And we'll hopefully end up with the same application that we've seen here in the showcase. And in between these sections, we will be answering a few questions that have come up by then. So let's pray to the live coding gods that nothing goes wrong. Let's hopefully get it done, get it right. Over here, I have Bootstrap, just an empty page, nothing interesting here. I will be moving on here into WebStorm and opening that page. And first of all, I've just prepared a small grid in here, just nesting two containers so that I have an easier time layouting the cards later on. So initially, as I've said, I want to fetch cards and display them. The first thing that I want to do, however, is even easier than just fetching the cards, because when I go back to actually the showcase application over here, you can see that at the top right-hand side, I have displayed how many cards there are in total. And this amount of cards or this data comes from an external API, and I will be fetching this. Interestingly enough, server components are running on the server, allowing us a lot of things that are not necessarily possible in classic client-side applications. In React, you would typically fetch data using libraries such as SWR or React Query, but server components are much more convenient. So let's start first by introducing a new component here. Let's just call it card count and use that one to make the request in order to download or to fetch how many cards there are available. What I'm going to do is very, very naive. I won't be using any external library at all. I'll be just using the fetch call. I have to keep in mind fetch is an async function, so I have to await the result and also make the component async, which is completely new. I will be mentioning that later again. And in here, I will be just copy-pasting a API that exists for Magic the Gathering, which just returns a huge data set of all available sets that exists right now. So since we are fetching here, I'm going to use standard web APIs to parse the response. I won't be doing any error handling or so because I want to keep it simple for the purposes of the showcase. So what I'm going to do is just to grab the response here and call the JSON method just to parse this as JSON. And I've already checked the API specification. So what I'm going to do next is just some, let's call it magic. I will be just iterating over all the sets that are part of this response of this body, and I will be just accumulating all the cards that are in there. So here this will break within WebStorm, of course, because everything is completely untyped. TypeScript will be completely complaining, but that doesn't matter too much because it will still work. So what I'm going to do is just to accumulate all card counts of each set, starting at number 0, and then eventually rendering a single div and say, well, we have the total cards to local string. Is a nice way to format that, and say cards in total. So in order to keep TypeScript quiet, we can just say, well, expect an error here because everything is completely untyped. And finally, what I can attempt to do here is to render this component. So let's see whether this actually worked out or not. So I'm going to switch over.
Interesting. Switching over, we might have to do that again. Hi, Christian. How have you been? It's kind of lonely here.
That happens if you toggle too fast between different browser windows.
Huh.
And
Who would
then
have guessed?
suddenly get lost. Yeah, unfortunate. So let's see whether this is working. So I've just hard refreshed this page, and now we can see that we have a response here. So let's get back into the code and discuss the new magic that is server components, because I've done a few things that are completely new to you if you have never used server components so far. First of all, I had the audacity to just call asynchronous function directly within a component. This is absolutely new. And typically, in order to deal with asynchronous things such as fetching data, we would either use effects, or as I've initially said, working with React Query, for example, or SWR to abstract that away. And consequently, whenever we are having a function that deals with asynchronous functions, it itself, of course, becomes an asynchronous function. So if I hover down here on card count, we'll see that the return type is a promise of an element. And the difference is, compared to client-side rendering, is that all of this is running on the server. It may take some time until the requests are done. And then once all the data has been loaded and everything has been pre-rendered server side, the final output is then sent to the client. In most cases, you will get just raw HTML. No JavaScript will be invoked on the client side. There is a set of few exceptions because there's a bunch of JSON that gets also sent down the wire. But generally speaking, you can assume that a lot of this is just statically rendered on a server and you get it right away. And what I really like about this new concept is that you don't necessarily need third-party libraries, and you can just write idiomatic code. You just fetch data where you exactly need it, and then render it without any weird abstractions on top of it. So there's that. Data fetching within server components, just do it directly, really convenient, opens up a lot of improvements when it comes to developer experience. Similarly to that, I don't only have the option to integrate or interact with third-party APIs. What I can do as well is interact with anything that is server-side. It could be a file system. To be fair, though, file systems have a few restrictions if you run it serverless. Or what I usually like to do, interact with databases. So what I have to do next is the following. I have a database prepared. For the sake of simplicity, I just have prepared a SQLite database, which is somewhere here. It's just a database with 3 columns. I can actually show it to you. We have here a cards table. And within this table, every card has a unique ID in the first column, its name, and then just an image URL that I will be using later to render. There are a bunch of different options to fetch data. What I personally like to do is use Drizzle as a query builder. So I've already prepared everything in the background. So I have here a database object, and I will just write classic SQL queries. So I will select from my cards table that exists, which, as we've seen, has a bunch of cards, 80,000. So I'm going to limit the results to only 20, just to keep it sane. And I'm just going to fetch, say, the name of all the cards that are in there. Similar to the fetch previously, I can just run server-side code directly within my component. Nothing of this will be running on the client side. So in most cases, you won't be accidentally leaking your database credentials or database object into the client, so people cannot really abuse this. You just write what you need. In our case, I can just fetch data or my cards in here. And down here within my grid, I can iterate over all the cards that I have and just say render out a few spans and render the name of each card. And I have to keep in mind, since we are in React, every time I iterate over a list of elements, I should attach unique keys to them. For now, I'll be just using the name just to get going before we check out the rest. So iterating over our cards, writing their names to the page. Let's see whether that worked. And you see already that all the cards, or the initial 20 cards, have already been loaded, fetched server side, and just rendered directly here into my page. All right, let's do some minor tweaks before we wrap up this first segment, because cards are there to be played with, but also artists have done a lot of work designing the art on the card, so we want to see a bit of that. What I can do next is introduce a new component. Let's just call it static image. And what I want to do is I want to render the image for each card. We need a few props for that. So let's say, what do we need? We need the ID of each card, I guess. And then we need the image URL that we want to render. Let's destructure that right away. And I'm just using the built-in image component from Next to do so. So I'm rendering the image URL. Let's actually use a random alt text, doesn't matter for now. And this doesn't work right away because the next image component expects some dimensions. So I'm gonna cheat a little bit and check out what I've already prepared, because I've checked what the dimensions are that are best for the screen size. What I'm going to do here is just add a width and a height for each card to be rendered accordingly. And I just made up my mind that I do not want to use the ID. I'm going with the name of the card so that we can have at least a little bit of accessibility, and just pass on the name of each card as an alternative text down here.
I like that. I think that's a good approach.
Yeah, I typically ignore accessibility until the very end when it's way too late.
La 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 la, I did not hear that.
All right, let's use the static image component that I have here instead of our spans. So let's remove this down here where we iterate over each card and render the static image. Let's pass the name, and we need some kind of URL here. So far, I haven't fetched the URL, so I'm just going to slightly adjust my query over here. So I want to fetch the ID of each card in addition to the image URL. So let's say cards table image URI. Well, the naming is a bit inconsistent, but you get the gist at least. Then what we can do down here is the following. I can then pass on the image URI or URL, and then finally use the ID, which is guaranteed to be unique for each card, in order to pass on the correct key property. So once again, let's hope it works. I'm going to swipe over, and there we have it. We have our first set of cards that have been statically rendered on the server side and then passed down to the client.
Sweet. Looks good.
Awesome. All right. Even though that was not a lot, maybe there are already some questions regarding async functions, async components, and data fetching.
We got a couple of questions already in the chat, so let's go through them one by one. And let me see this magic and get it on the screen. Bam. So we have one question. Where does the table come from? Did you import it up front? Where's this data coming from?
All right. So I've prepared within this project a database folder By the way, we will be sharing the entire project with you afterwards, so you can, in your own time, check out the source code. And within this database file, as said, or that I'm using Drizzle as my query builder and ORM of choice. And I'm just declaring the tables that I am using and just referencing my local database here. I could, for example, wire up any database online, such as PlanetScale or anything on AWS or Neon. It's just for the sake of this webinar, and to keep it simple, I just opted in to use SQLite for this. And this is the database interface that I'm using and interacting with to fetch the relevant data.
And you basically had like a set of like basic data that you were able to import at the very beginning. Is that correct?
Yeah, I've just prepared the database beforehand. There was an API and just did set up the database, as you've seen, with some initial data here to work with.
I thought you just entered the 80,000 records by hand.
Nah, that would be way too much for me. I would need to ask for a raise in order to do that.
Fair. All right. Jumping to the next question. By the way, there's no such thing as a dumb question, so we just skip that part. But how do you know or control which bits are run on the server versus on the client, or do all components get run up by the server?
All right, that's a really good question. We will be seeing the answer to that later, actually. But generally speaking, the default is that all the files start out, or all the components within the files start out as server components, and they are running on the server. You have to explicitly mark what is running on the client, and we will be seeing on which circumstances and in which cases you actually have to do so, because there is a few cases where you just cannot run the code on the server, especially one example, for instance, if you try to access browser APIs, the window or the document that doesn't exist on the server.
Makes sense. All right. We got more questions, so I'll just shoot them your way. How are server components different from get server-side props?
All right, this is a next specific questions, so I'll try to keep it short. Get server-side props allowed you to do server-side rendering by fetching all data within one specific magic function, because it has to be a specific export at a specific place. What server components allow you to do is to move the data fetching directly into the component where you need it. If you had a much more complex application in Next that required a few sets of data across multiple components, you would have to fetch everything at the root in the get server-side props method. And you have seen here, for example, I fetched specific data for the card count component, and I fetched my card separately from that over here. And in addition to that, server components allow much more than just the get server-side props. They are more versatile in terms of additional features. We'll be seeing the mutations, which are implemented using server actions later on. And also, it's arguable that a few things that you would run in get server-side props that you had to smoosh together somehow can be easily refactored and moved to where they are actually needed, as I said, which is really convenient in terms of TX.
Cool. So now coming to a little bit of a controversial question, but I had that same question as well in the beginning. How is this different from PHP?
It's not. Yeah, jokes aside.
Good answer.
React Server Components is definitely lending itself a lot from, or borrowing a lot from PHP or Rails. The difference here is that you not only have the capabilities of the server where you can execute your server-side code, but also the interactivity of JavaScript. One thing that is very interesting, unfortunately, I have to say that all the time, we'll see it later. With PHP, typically, when you issue requests, perform actions or whatnot, you would be reloading the entire page at once. What server components allow you to do is to declare certain parts of your page as interactive and then only refetch what is necessary. To show it, for instance, here for the showcase that I've prepared earlier, whenever I press one of these buttons, PHP would require to refetch the entire page, or it would require some jQuery magic to reload certain parts only. But what server components do is that everything will be rerun on the server, and only this area where the one is rendered is being actually re-rendered, and everything else is kept the same state, is kept persistent, which is really, really convenient. So basically, server components can combine the power of server-side languages such as PHP with the interactivity of JavaScript on the client side.
That was a very good explanation. Thanks for that. Appreciate that. And one more question that we got in the chat, and I think you'll talk about that later as well. But what is the most elegant way to have server components refetch its data in response to some action taken in a child component?
We'll see that later.
That's what I thought. That was a good teaser. Like, we will come to that later after a quick break.
Yeah, I should have started to take count how often I will be relaying or saying we'll mention it later.
Sweet. All right. Any more questions? I'm just quickly going over the chat. I don't see any. If there are more questions coming up, just drop them in the chat, and we will come back to that later. So having that said, feel free to take us along.
All right, let's work on the next big thing, filtering. So when I go back to the showcase application, I hope you're not getting too dizzy when I switch back and forth all the time. You've seen that I have an input box here. And my idea here is that I do not necessarily want to fetch all 80,000 cards and then filter client side. That would be just a waste of energy, of transferring data over the wire. What I want to do is to filter server side. So for that case in particular, we have to decide on how to actually send data to the server for specific requests. And this is one of the first things where a slight mental shift is required. You have to consider pages as the result of GET requests in terms of classic HTTP requests. And you have to figure out how you want to pass parameters. And one of the most common ways that is very idiomatic is to use the URL, because everything that runs on the server is completely stateless unless you have a very, very unique use case.
Ideally,
yeah. You should just attach everything that is necessarily for the request to be properly processed as part of the URL, or maybe some headers. So what I want to do here is to deal with the server-side logic first. My idea is the following. Whenever I want to filter, I want to attach a query parameter, say name, and then, for example, filter by Teferi. So the idea here is that our input box that I add to the client will then change the URL accordingly and then refetch what the server does. And this is really interesting because filtering typically requires a bunch of boilerplate, and using server-side logic and server components, this becomes a lot easier. First of all, I will be leveraging...
Sorry, real quick to jump in. Would you mind elaborating on how this makes it more effective, like filtering on the server side?
Yeah, so typically what you would require on the client side, if you want to filter client side, is first of all a state variable that, for example, holds everything that was fetched from the server. Then maybe have a state variable that holds the current text that you've entered into the filter field. And then you would require a computed value, have to filter manually there, and then hopefully not run into too many re-renders or run into stale state if people use way too much state for that in order to render all of that. And what we'll be seeing next is that filtering is as easy as just adding a single line here, assuming that your data fetching logic supports that.
Yeah, I don't think I could implement client-side filtering in one line. So show us.
All right. So the first thing that I will be doing here is leverage something that comes from Next specifically, which is just a quality of life feature. What Next does is everything that is passed here within the search parameters for the URL is available for each page. So there is an object called search params, and I can say that I'd expect a name in some certain cases that I want to interact with. Do note, however, this is TypeScript. This is no validation that the name actually exists. It's just for me that I have proper completion and proper documentation on what I expect here. And what I can do next is a bit of trickery. Over here, since we have just SQL, I can write a filtering logic using the where clause. And there is a function in SQL called like, where I can say, okay, use the name field from my table and match it against a specific string. So what I'm doing here is using the percent sign as a placeholder, and I will be interpolating this string. By the way, this was automatic string interpolation that I introduced to WebStorm during the last release, so I didn't have to do that manually. I can now insert from the search params the name that is part of the URL. And since this is possibly undefined, I'll just for safety purposes supply a default value of an empty string. So there are two things to mention about this line in particular. This is already sufficient enough to filter on a database level which elements I want to, or which rows I want to pick. And the second thing is that this is absolutely a bad practice in terms of SQL. Just to mention it here, usually you would use match against on a full text index, because a like operation that uses placeholders at the beginning and at the end just cannot leverage indexes at all and will go over the entire table. So this would explode your billing. So I'm just using it because this is running locally in SQLite and because it's easy. So let's give it a try and see whether this actually works. Keep in mind, this is only server-side what I just added, this single line here. So what I have to do is when I head over back to my application, I have to try to change the search parameters here. So let's, for example, filter by Nicole, which is Nicole Bolas, one of the Elder Dragons, and we can see this works already. For the purposes of this presentation, I've already prepared a small debug component since my URL bar isn't visible, so you can at all times now see which URL we are currently navigating to. What I can try next, for example, is I can filter by Chandra again, for example, and we get all the data which is filtered on database level without anything added on some kind of client side, and it was basically just a single line. All right, so apparently server-side filtering works. Now on to the input box. What I can do next is over here, try to add the input box. I say it's of type text, and it has some kind of on-chain handler that listens to whenever I type into it. So let's save this and head over to my application, and we are greeted by unhandled runtime error. Luckily enough, this was to be expected. If we see closely what it says event handlers, such as my on-chain function over here, cannot be passed to client components. So earlier on, one of our viewers already asked about server and client components. And this is our very first time that we've run into this specific boundary between the server and the client. Generally speaking, as I've said, server code is stateless and doesn't necessarily know anything about its clients. And anytime you need some kind of interactivity. So typing something into a text box and handling that. Or maybe you need to access the browser APIs, document, window, or whatever. This needs to be handled in a specific client component so that code for server and client is separated. Let's do that. So if you need interactivity, consider converting part of this to a client component. Sounds reasonable enough. So what I'm going to do next is the following. React has chosen a specific syntax for client components. I personally don't like it too much, but let's go with it. Over here in my app folder, I can create a new file, and let's just call it components.tsx. The name doesn't necessarily matter. You can use anything, almost anything that you want. And what I can do next is export a function. Let's call it search. And let's just do the very same. So let's use a text box, add an event handler over here that listens to that. This still isn't a client component. As I've mentioned earlier, everything is considered a server component by default. In order to mark this as a client component, you need to add a directive at the very top that is called use client. You may recall from back in the past where people were using use strict. This time we're going with use client. What's important here is the following. This use client directive applies to the entire file. So if I have additional components later on within this file, all of these are all considered client components. So I have my search box. I've marked it as a client component. Let's see whether I can use it without any issues. So I will go back to this page here and remove this input with my search. I will import the new one because I've prepared some fallback code in case things start burning. And switching over to my page, I can see now that the input box exists. I can type in there and nothing is crashing, which is actually quite nice. So once again, if you need interactivity, you need something locally with the client. For example, you want to interact with the local storage. It must be a client component in a dedicated file that has the use client directive at the very top as the very first instruction. So let's start thinking about the actual client-side logic for this search box and what it entails. So I've said that every time I type into this box, I want to update the URL and update the search params at the very end. For that, I will require a few things. First of all, I will be interacting with the next router itself. For that, there is the use router hook, which exposes the router instance. With that, I can later navigate onto certain pages. What I have to do next is that I want to actually extract this onChange handler. And I want to show you something interesting. People typically struggle with figuring out what is the right type, especially if these functions or these event handlers are extracted into their own functions. If you Alt-Enter or Option-Enter over here, you can head down to the Specify Type Explicitly option, and WebSum will automatically deduce which type this actually was and then add it in here. Then, by hitting Command-Alt-V, no, that was actually the wrong one because I accidentally hovered or highlighted the type itself. So let's try it again with my cursor here on the method. Command-Alt-V. I can now extract this to a function itself. And if I would be typing much faster, it would actually be way more impressive than that.
That was very impressive, though.
Awesome. Thank you. All right. So let's think about the implementation of unChange. This is not necessarily specific to server components, at least for the most part. It's just some basic web APIs. So I'll be going a bit faster over this. So what I'm going to do is to grab the current search params, so everything that is after the question mark, if there are any, using the standard URL search params class. I will then use the window location search property and pass it in here. Window is a object that only exists on the client side, so this would be the latest that we would need to resolve to client components. Then I can check if there is already some text within the text box. So I will grab the event, pick the target, which is our input element, and then the value. And if there is actually a value in there, what I can do is use the search params object, which is pretty much just a map, and it exposes a set method. And I can say, well, just set the name property to whatever I just typed in the text box. And this is really convenient because it doesn't really require any specific state within the component. It's just grabbing the value whenever I type or whenever I finish typing, and it just appends it. And in the else case, this is when the text box is empty. What I can do is to clean up the URL to make it slightly prettier. There is the delete method, and I can just delete anything that is currently in the name value. So now comes the tricky part. Under normal circumstances, I would start or use the router, and I would replace or push the latest URL. This is next specific once again. I'm picking replace because I do not want to spam the history with everything that I've ever typed. It will be a bit of a waste. And what I can do here is to start building my URL. Since I only have the search params, so everything after the question mark, I still need everything that comes before that. There is the path name hook that allows me to grab exactly that within client components. So that would return /foo, for example. And then I can just insert it over here. What was it? Path name, and then add a question mark followed by search params, and then toString. So using the entire map of all search params and then building a single string out of that. I've mentioned moments ago that this is a bit tricky. It will work, but there is something new in the context of server components and in the context of React 18. So if you have ever worked with a lot of state, you may have run into the scenario where a few state transitions that you wanted to do have been delayed and not executed right away. What React does under the hood is that state transitions, whenever you want to change state, it batches them and runs them whenever it's the most suitable. In our case, interacting with the router is also a state transition that incurs navigation, which might take a while. And state transitions in React are all synchronous. The worst case scenario that can happen is that navigating can take a while and your application or your website becomes completely frozen. It becomes unresponsive, which is really, really bad. And in order to deal with this, React 18 has introduced a new hook, because we love hooks so much, called use transition. Use transition is very cool because it provides two different things. First of all, it provides you a Boolean flag that people usually call is pending, which allows you to render some kind of loading indicator, for example, whenever you start a transition, so start a state transition that might take longer. And the second object within this tuple is a function that is typically called started transition. Really difficult word, actually. And what I can do now is the following. This entire snippet where I replace the current route, I can wrap using the started transition call, and I can just place it in here. What happens now is that This state transition is explicitly marked as asynchronous, and your UI will remain responsive, and it will then refresh whenever the server has finally finished with the request, since you are routing to a different page. And if I would be interested in that, I could just add some kind of spinning indicator here at the end based on the is pending property over here, but I'll just skip that for now because I'm more interested in seeing if everything still works after this long part or this long snippet. So let's give it a try. I'm here. I'm just going to refresh this for this purpose of punching the cache. And I'm going to start typing. And you can see whenever I change something, the URL refreshes over here. And new data is automatically loaded from the server. And I can fetch for Karn, for example, or for Nissa or other cards. This means server components can be rerun whenever you change the URL. There are a few more steps to that or a few more options for that, but one of the most important things is whenever you navigate, they are rerun. In our case, we are staying on the same path, but we are changing the query parameters that we are passing. So if we go back to the page itself, what happens here is that the search params are new cards are fetched from the database, and then all of this is re-rendered. And what's really cool about this is that while everything gets re-rendered on a server and then sent down the wire, locally within your client, it will be reconciled in such a way that only the changes will be applied that you are usually used to whenever you deal with React. So this is not necessarily something completely new. This is also one important aspect why the key property, for example, even for server components, still exists. So whenever the order, for example, for images has changed, React on your client side can then recognize that whatever just came from the server side maybe shifted around, the order changed, or maybe a completely new element ended up in there. So once again, in order to let the page, for example, which is a server component right now, re-render, you just navigate to it, maybe with different properties, and then only the changes are then applied client side. There is another way to do that. We'll see it later once we deal with the mutations. All right. So what we've seen now in this section is we need specific client components within files that are marked with this directive. And within these client components, we can finally interact with event handlers that we've written ourselves, for example, or we can interact with browser APIs such as window, local storage, and whatever floats your boat in that case.
Can you show the network tab real quick just to showcase what goes over the wire in the end?
Yeah, so this is unfortunately a bit tricky. Let's see whether we can see everything. So whenever I start typing, let's just type one single letter. Of course, I'm fetching a bunch of images, and here the very first entry in my network tab should be actually, or not. Let's see whether I can get it working. There, okay. So I just navigated to a different page, and we can see that these cards are all listed in here as the images. And something you might be interested in, what happens here is that there is a bunch of JSON. It has a different form because we're currently in a local development server. Gets also sent to the client, which is then used to reconcile the data that comes from the server side and with what is already available on the client side. So at the cost of slightly more payload that gets sent over the wire, we can get a faster response time or faster rendering time because most of the things typically get pre-rendered on the server, which is really convenient.
That looks like framework magic that I, as developer, don't really want to deal with.
Yeah, in most cases, it is completely fine, and people don't necessarily have to bother with that specifically. And we just pray that all these people that are much smarter than us get this right eventually. And one thing I actually want to mention before we may head on to some questions is another misconception. What's important is that even though components can be marked as client-side components, they are still pre-rendered on the server side, just without any interaction or JavaScript. This is specific to Next at the moment, because it provides the ability to still have proper search engine optimization. Otherwise, your page would be completely broken on the first navigation without any JavaScript. Would be really bad, I guess.
So you sorry, just for my understanding. So you're saying that even though you use client, React still apply server-side rendering on that component? Next.js does still apply.
Correct. So if I would, for example, attempt to access the window object here, chances are very high that I get hydration errors or something breaking. I just have to force it somehow to break, or maybe it gets optimized out.
I
But
was just
generally,
saying, like a bundler should throw that away as it's not used. But
yeah, chances are high that it is the case. I haven't specifically tested it out, but in the bunch of help channels that I'm in, I'm seeing constantly people being confused why they can't access window or local storage, even though it's marked as client side. It is still pre-rendered on the server.
Seems like an unintuitive default to me too. But cool, that's good to know. So let's jump into questions because we got a couple lined up.
Of course.
Let me see if there's a good order we can go through them. So actually, we talked about filtering earlier and stuff. And while the developer experience is nice, or what you said, what about runtime performance, and like how does it affect the user in the end? That's one of the questions, if I summarize that correctly.
So filtering is, so generally speaking, in web development, tables, date pickers, and filtering are probably, apart from caching, one of the most difficult things that you can deal with. Within the question, I just saw the mention of debouncing. Of course, you would try to not DDoS your own server with that. And within the code, where is it actually? Was already here actually. Add some debouncing to this on-chain handler, whatever tool you would use for that. For the sake of simplicity, I just left it out. And it really depends on how much data you have. For instance, if you know that you only have like 100 elements or 200 in your database, then it might just be easier to send everything down to the client and then filter client side, which may be a better user experience. It might be faster at times. But in the case of fast data that is changing very quickly, that is getting stale really fast, or data where you have a huge amount of data, it might just make sense to deal with that on the server side and just leverage the power that a server actually has instead of just shifting everything to the client side. But as usual, it really, really depends on the context in which you are working.
But I mean, the nice thing is we know about the power and the processing units and stuff of our server. We don't really know what phone, laptop, tablet the user might use, so it just makes it a little bit more predictable. Is that what you're saying?
Indeed.
Cool.
That's true.
Coming to the next question. That's actually a really good one. I was wondering about that too. What about security?
All right. In terms of security, you have to remember that everything that is part of the code of a server component, so say this here, is running on the server itself. It will never leak directly into your client because only the rendered output of the component plus some JSON describing it is sent down the wire. In the same fashion, you could, for example, use environment variables. So it can come up, let's do something very stupid that won't work, but still process env limit count and then fall back to 2. I technically have to parse int this. get it working, and I still have some
I would assume
bugs.
type
Anyways, my point here is that within server components, you can easily use environment variables. They are not necessarily exposed to any kind of client-side code, unless you, of course, have some bug where you accidentally import or export certain elements where they are not supposed to be. And for that in particular, there are a few helpers. First of all, frameworks implement a bunch of security features to prevent environment variables for leaking. In terms of security, I'm always thinking of environment variables because they contain API keys. That's why I'm so hung up on them. And the other thing is that there is a package called server only. It's used to poison certain parts of your code, where you can head over here and I don't have it installed now, but still you can say server only, and then you will get an exception whenever anything from this file suddenly reaches the client-side bundle. So you can go ahead and strictly mark everything that should be kept on the server if you really don't trust the automatic heuristics that the React compiler and whatnot provide. And other kinds of security, what I can think of, as we've just had a similar example, is in terms of DDoSing and debouncing requests. You should still use something like rate limiting and whatnot to prevent users from breaking your server, because this is, of course, a new paradigm where things don't necessarily only run on the client side anymore. You shift a lot to your own server. You expose yourself there, of course, and you need to take the correct steps or measurements to prevent getting hacked, or not necessarily hacked, but DDoSed most of the time.
And also, just for the sake of completeness, use everything with a little bit of caution. We're both not security experts. We have like a general interest in security and as developers, but none of us is seasoned enough to make well-defined statements about that. So just take it with a little bit of caution, but as long as you make sure your server is protected in a way you would usually secure a server, you're at least from a development perspective on a good side. But it's also very new tech, so we will. I'm pretty sure we'll see more things about that in the very near future.
Indeed.
Cool. Do server components have a life cycle like client components?
No. So lifecycle methods are client-side only. If you require some kind of lifecycle features, do them in client-side components. And with that being said, client components aren't bad. If you need them, use them. There's nothing wrong about that. It's just convenient to shift the things into server components where it makes sense, such as data fetching and co.
Cool. Coming to the next one. What is running this in the background? Typically, the server only sends the bundle to the client, like Webpack Dev Server or some other dev server tool. What is running this whole thing right now that you're building?
So this is new to many people. Typically in a fully client-side rendered application, what the browser would do is it would fetch the entire bundle and would fetch React as well and run everything locally. For server components, you need a server running in the background. It's just a simple node server. You can implement it yourself. There are a few examples for that, but whenever you use a framework such as Next, and in the future, most likely Remix as well, you will get this all out of the box. And in that case, the server components will allow you to stream to the client only what is necessary. It's not necessarily, or it's not strictly only part of server components, but concurrent React has been introduced in React 18 and allows you to stream in parallel whatever you need and even prioritize the respective bundles. So you would then ship less data over the wire in the best case scenario, and therefore have a bunch of the things, as I've said, pre-rendered on the server and get it directly to the client.
Cool. On a similar node, what if we use a separate server?
That's a difficult question because I don't fully understand that.
So from maybe player, you can respecified, but from my understanding, it will basically be we have our server deployed externally and the client part of the application on a different server hosted in a CDN or something, which I don't think is really the mental model here because we pre-render the client components as well, or server-side render them.
Yeah, in most cases, you would keep everything on one server and deliver the data from there, if the question was hinting at that.
Yeah, if we answered a different question, feel free to respecify in the chat. That's actually a great question. So you're saying sending HTML to the client get rendered faster in UI instead of sending JSON data and update the DOM on the client side. Is that a correct statement?
Yes and no. So the internal details are a bit tricky. So the HTML gets sent down the wire. That is a fact. But in addition to JSON gets also sent down the wire. The JSON is referring to the virtual DOM that gets pre-rendered on a server, so that the reconciliation process on the client side is much faster. So on the client side, nothing needs to be computed. It just needs to be slotted in wherever things have updated. So in that case, I forgot the terminology for that, but you send slightly more payload. This is your cost. And have the advantage of having things run slightly faster. In most cases, we're quite lucky because React is fairly fast already. In, I guess, 90% of the applications people write, they will never run into performance issues with React. But still,
Bold statement, but
depends on how they write it. At least from what I've seen over the years, I've never seen React-specific performance issues.
fair.
I don't know how to interpret that specifically. But at least in the future, we are already armed in a sense that less work on the client because everything is done on the server that can be done on the server with some additional data that can send down the wire.
Cool. We talked a little bit about security and we touched on that earlier, but I just want to reiterate. Does the component code get transferred to the client at all? Could I, for example, use secrets in my server-side component that the client is not allowed to see?
Yes. So if you use server-side secrets, use them in server components, nothing of that leaks into the client. If you want to be very safe about that, use the server-only import that I showed earlier. This will make it even more secure because it's very explicit about that, because everything runs on a server that is a server component. Only client-side things end up in a client-side bundle.
Sweet. Talking about bundling size, that was a fantastic transition. How does bundling look like for an application that has both server and client components?
I haven't been diving too deep into that, but there are separate bundles. So server and client part, only the client bundle gets sent to the client, so a part stays on the server. And I can mention one thing here. There is a really cool thing about that. If you have a lot of work to do or want to handle a bigger workload, for example, syntax highlighting. Nowadays, there are syntax highlighting libraries that work in the browser. Previously, they didn't. You can just drop all of these syntax highlighting from the client, move it to the server, run it there, and the consequence is that nothing of the syntax highlighting library ends up in the client bundle.
Sure.
So you can move big dependencies that can be run on the server over there and then make the client-side bundle much smaller.
That's pretty cool. Yeah, that's a good use case. That's true. There are a lot of questions, so let's keep going with them. Here, what about your images? Right now, I think you didn't use any loading parameters. So are you loading them in eager mode, or how does it work?
I'm not bothering about images at all right now. I'm just using the image component of Next and just hoping that it does its job. What it typically does is it will resize the images and then do its thing. To be very precise, since the image component is a client component itself, it doesn't run on the server. it will just request client-side the specific URL. We can, for example, check it on one example here. If I inspect this image, you can see that there are weird URLs here, which is just an encoded path to the underlying image endpoint that Next provides to resize this. And all of this is then fetched client-side because the image component itself is a client component.
And
I just didn't
there
mention it at all.
it is also using the lazy property by default, so that seems to be a next.
Oh, I haven't
convention.
seen it. Let's check it again because I'm curious as well. As I said, I haven't looked too much into it.
Loading.
There, loading lazy indeed. Yeah.
Huh.
Because that's just how Next optimizes it. I haven't been dealing too much with image optimization myself, unfortunately.
One question again about bundle size. Could we check what is produced in the client-side source code? I would assume you have some kind of dist folder. I personally don't really want to go into bundled code right now because it gives me ick look at all that optimized code. But it should be generated in a dist folder public, something like that. And if you check out the repository, you can look at it yourself if you're interested.
One info here is there's the Next Bundler, which is a plugin that can be added to the Next pipeline, which then creates a nice graphic on what ends up where, and then you can see actually which packages end up in which bundle specifically.
Cool. That's good to know. That is a really interesting one. Could we do a hot module replacement with server components?
There is a lot of ways to interpret this question. Server components allow insane patterns and ways to interact with them that are way too advanced to show them right now, because even I haven't checked out a lot of them. There is a great many things that can be done with it, and I think HMR is part of that as well, if I interpret it correctly.
Cool.
Should we head on to the final part before we get stuck in too many questions?
So there are... Yes. Well, yes. Let's table the following other questions. I have them still tracked, so we'll come back to that later, but let's hear the rest of the presentation.
All right, cool. So let's get the final part done, then we can spend the rest of the time on questions. As you've seen earlier in the showcase, each card here has these buttons to mutate the data in the database when I click on them to update the amount of copies I have. And you may have noticed that this is a bit delayed. Don't know exactly what's going on. Maybe my computer is running slow. And this is what we will be implementing next using server actions. Server actions are a really cool feature that allows you to define functions on the server and call them from the client without thinking too much about them and without having to deal with manually fetching endpoints or similar things. So one of the examples I can do is that we can, let me quickly think how we're going to do that. First, I will change our current image component that we have. So I'll just head over and copy paste what I've prepared over here. Let's see. Just have to find it. What I'm copy pasting now is completely irrelevant to the context of server components or server actions. It's just a new alternative version of our image components. I'll just try to import as much as possible and get the errors, or terminate all the errors that we have. So let's see, let's import the image component, or maybe not. No, that was too much. I just want to import from next image, I think. All right, nothing is red anymore, which is really cool. So let's check it out. I have this new component, animated card with quantity. It wants an ID, name, URL, and quantity. I will go back to the page now and just replace my existing component, which was just a static image for now. So animated card with quantity from my new thingy here. I'll pass on the ID of my card, the name of the card, the URL that we already have luckily, and the quantity, let it be 0 for now. And let's not forget the key property. It was I did way too much. That's happened when I type way too fast. So let's see first whether this is working now. This is the showcase. This is where we want to end up. All right. So right now I've just replaced the cards with these cards that have these buttons. And whenever I click on them, nothing happens. And this is the next step. We'll add some interactivity with that, which actually uses the new features. So server actions are functions that are defined in server-side code. So let's remove that for a moment. And let's just call this function onClick plus button, maybe. And what I want to do is to add some logic in here to increment the amount of cards in the database whenever I call this function. And in the best case scenario, I would like to be able to pass on this function as a property down to my component. So onClick plus, for example, and then just do this. Of course, onClick plus doesn't exist yet on the component. So I'm just going over here and adding this actually. OnClick plus is a function that returns void maybe. And I'll use it later. Yeah. And let's go back to my page file. So it's not read anymore. And when I head over here, once again, we have the same issue. I cannot send down handlers or functions to client components. Now comes a tricky part. There is one way to do that. And it's meant to be done for functions that are mostly mutating data. Similar to the use client directive, we can go to this function here and add a directive within the braces here called use server. This marks this function specifically as a server action. It has to be asynchronous as well, otherwise the server will complain and cry. And if I head over here, it seems to not crash anymore, which is cool. So I've said the following. This function can be passed down to client components. And within this client component, we can actually call this function. So let's give it a try. So I have this onClick plus function here, already destructured from the props. Somewhere down here, I have a div that I'll attach a onClick handler to it. Please don't hate me for adding a click event handler on a div that is not a button.
Shame. Shame.
So I'm just calling the onClick plus function here. Right now, this function itself doesn't do anything. So let's do one thing. Let's head to the function and debug like every good JavaScript developer would do. Console log, you clicked me. Now I'm heading back to this page, opening up the DevTools, heading to the console, clearing all the warnings for the images, and then I will be spamming the plus button, and nothing is happening. The console is empty. Well, I mentioned that server actions run on the server. So if I head back to WebStorm and check out the console for the dev server itself, the dev server says that I clicked the button. So what happens here is that you can write a bunch of logic, mutations, often for interacting with databases and similar things within these server actions. They are once again completely separated from the client-side logic and call them. Under the hood, what happens is fairly interesting, because if I head back over here and instead of checking the console tab, I check the network tab, I can clean this and click once on plus, we can see that a fetch request is being done to some server action reducer method. Oh, that's a huge tooltip from the browser. I don't want to see that. And we can see that this automatically sends a post request to my page, or at least to a route that is mounted on the same page. So basically, server actions are a convenient way to define endpoints or API endpoints that you interact with without having to manually fetch them or handle any kind of payload or whatnot. You just call them as if they are like any function. So what I can do here, just to get at least that button working, is to rewrite this function. So I want, for instance, to increment the amount of copies I have for a specific card with a specific ID. And for that, I need some database logic here. The logic itself is completely irrelevant, to be honest. I'll just copy paste it so that it's running. So let's just import everything that is necessary. This is just some SQL that will ensure that whenever I click, the card with that particular ID that we pass to that function gets +1 in the database.
It's a little bit like one of those cooking shows where at the end it's like, oh, I prepared this roast already up front. It's like it just took like 5 hours in the oven, but I'm just
gladly. To be fair, though, the code that I wrote is pretty bad, so I don't want people to see that. And for the purpose of this showcase, it doesn't matter.
No one saw that.
One thing we have to fix, though, before we check out the rest is that this onClick plus function now expects an ID of the card that we want to increment, or at least the copies of the card that we want to increment. And then we can just pass within the plus button the ID of the card. There are two things we have to deal with before we can check whether this works. I was very quick with this quantity here. I'm just hard coding a 0 right now. What I want to do is I want to fetch more. I want to actually fetch the quantity of each card from my collection table, which is the second table that I have. And once again, I will be doing that using just some classic SQL. In this case, I will be just performing a join on the data. So I'll be joining my collection table and my cards table on the ID of all the cards. So I will join the collection table here on the left side, where the cards table dot ID equals collection table dot ID. So data fetching in my example is super nice. Every time we need a new feature, just add a single line, and then we can just replace the 0 with the actual quantity. And since the quantity could be possibly null, as you can see, let's just keep it safe and pass on a 0 in a case where we don't have any entries. So what do I expect? I've passed on my server action, which does a bunch of magic with some database inserts, updates. In particular, it just does an upsert. And what I expect now is whenever I click the plus button, say on the Stormcrow, for example, I will be getting one more card of it as a copy. So I'm going to press it a few times, and apparently nothing is happening, much to my surprise. So let's refresh this page again, and we suddenly see that Stormcrow, 14 copies. Something is wrong here. One thing to keep in mind is that even though we can send post requests, it doesn't mean that there is some follow-up necessarily to it. It would be pretty bad if the entire page would automatically refresh. So what Next provides here is a function called reValidatePath, which allows us to say, okay, after I've invoked this server action, I want this path to be re-rendered. And since my client that is currently on that path is issuing this request, it will automatically get the updated version. So fingers crossed, if I go back to the application here, and let's take Ravnica at war, even though war is very negative, let's click a bunch of times on plus, and we see with a bit of delay that this is increasing. And this is actually one of the cases, again, where you could technically use the use transition hook to prevent the UI from becoming unresponsive, and then maybe like show an effect on the card that currently something is updating. But technically speaking, this is the way how you can pass functions to server-side logic directly down to client-side components, and they don't have to bother knowing about endpoints, fetching, or whatnot. You just call your function directly and it does its thing. And the only thing that is required for that is that those server actions are marked as asynchronous and use this very debatable use server directive as the very first element within its block, because this makes the compiler actually recognize what is considered to be a server action.
Magic strings are totally fine, and there's nothing wrong with them at all.
There's way too much to argument debate about this. At least it works for now. We'll see whether things change in the next few years. All right, so this is basically everything in the context of server actions already. I can show you just one small thing over here in the final showcase code. Even though it has a bit of other code, I just have a similar function which removes cards from the collection. It even has a better name. It does some database magic, and similarly, it calls revalidate path. And at the very bottom here of this file, I just pass on both functions down to the client component and call it similarly. And then we can be happy that I can finally add and remove cards as necessary.
Can you show the add and remove one more time in the network log? It's just really,
Yeah, of course.
I think it's cool that this is already like integrated and stuff.
So here's the network tab. Let's take warlocks because we like evil things. So when I press plus, we see that there's a post request over there. And once I click on the minus, we see that this gets down to 1 because there's another post request with the payloads, specifically which card is.
Can you show the headers again? It looks like it's the same endpoint that is called.
Yeah, indeed. It is actually the same endpoint. It is handled by a reducer in the background, and it just distinguishes what call you did. So technically, you could, if you somehow reverse engineer that, just issue calls yourself without dealing with the magic that is running underneath.
Interesting.
And generally speaking, these server actions are really convenient if you want to expose backend functionality directly to be callable from client components. That doesn't really need a public API endpoint specifically. All right. That would already be that section.
Cool. Well, thank you very much again for showing all that and going over the questions. There is nothing else we want to demo, so we can switch to like the two-speaker fancy. This one, so fancy.
You're a magician.
Yeah. Without Haynes. It's like AI and stuff. We will share the link to the GitHub repository in the afterwards, just that everyone can check that out and play with it themselves. We do have a couple more questions lined up, and trying to be cognizant of everyone's time, even though we're already 30 minutes over. Let's go through them. So, that's a great way to start questions, and I like this question so much. Which IDE and extensions are you using?
I'm using WebStorm.
What?
I might be biased because I'm working in the WebStorm team, and it's really cool because there are no extensions necessary. WebStorm supports everything out of the box whenever you want to deal with JavaScript, unless you have some very, very specific things you want. So you get a lot of things right away, which is super nice.
Cool. What's the difference between server-side rendering and React Server components? And I had that question myself. I Googled it yesterday. So
if you've Googled it, do you have an answer?
No, you got this.
So in terms of server-side rendering and server components, The biggest differences were streaming that I've mentioned earlier. With server-side rendering, you would get just the entire result and just display it. For example, the old school style with PHP. You just make a request in a multi-page application and just render whatever you get as a result. With server components, you have way more granular control over what things change, so that in the best case scenario, all the state that you have on the client side is still persistent and you do not lose it, and things only update whenever necessary. One of the examples was in the showcase when I type something into my text box and I just mutate by clicking on plus and minus. The text box isn't getting empty all of a sudden. It still contains its state or its content, which is really convenient. That's like two of the things that come to mind right away.
Cool. Next question. Can I use server-side components with different API calls routes that can be used externally? So can a third party or another project call my APIs that I provide in my React server application?
Technically, yes. It's a bit tricky right now. What's really interesting, since server components themselves are sent over as HTML and JSON, you could even provide APIs that send server components as a response. So you could technically figure out if you really want to do something like micro frontends or whatever in the combination with server components, even though I highly discourage doing that. So it's definitely possible that you send components down the wire because they don't contain JavaScript specifically. They are only static. The only thing that you have to keep in mind is whenever some client components are interleaved in between, where it's then necessary to figure out how to hydrate that correctly, which luckily the frameworks will do for us unless you want to get your hands dirty.
Just a question from my side on that, and is the payload in a standard format? So would a React or a Next server component or an end action work with a Remix server component end action?
I don't know yet because Remix doesn't have anything yet.
Fair.
There are a few things that are almost standardized in React, but they are not fully stable.
Yeah. Okay.
They've reached the state of being able to be implemented by framework authors, such as the Remix team or Vercel. We'll have to see. I know for a fact that Ryan Carniado from Solid.js is already looking into a bunch of fancy advanced things that he wants to do with others.
Okay, we have 3 minutes to keep it somewhat on time. How to determine whether an event handler involving data update should be a server action or a client-side one? It is based on updating the target database or browser, or how would you handle this?
Well, so event handlers, whenever you interact with client components, should be client-side anyways. The question here is whether you want to interact with an API endpoint, or use a server action. In most cases, server actions, once they become fully stable, are much more convenient because you don't have to hard code URLs or figure out some way to deal with them. It's just call that function and it works. There is a few things with server actions that aren't going well right now. There is no error handling established right now. So whenever you want to do client-side fetching as part of mutations, you can just use your classic libraries that you already use, be it React Query, be it Key, or similar things that provide all of this out of the box.
You very well touched on this question. Is there a use case for complex data fetching libraries like React Query with the advent of server components?
If you use server components heavily, you might not need React Query. You can pass initial data that you fetched on the server down into a React Query store if you want, which is really convenient if you want to refetch something very specifically without navigation or without using actions that call revalidate path. For that, I want to suggest a blog post from Dominik Dorfmeister, TK Dodo. He's the maintainer of React Query. He has a very good blog post called "You Might Not Need React Query," which is really cool. You should definitely give a read.
Yeah, the only scenario that I could think of for React Query would be like advanced offline scenarios where you want to cache something like on the device, and therefore, like you expect you don't have an internet connection. That would be
That
like,
as well.
yeah. Okay. If I use fetch and server components and do not use revalidate path, will it show the same result always after building?
All right, this goes already into next extra features on top of React Server Components, which is caching. Next does a lot of features to provide static data fetching so that things do not have to be refetched on each request. Things are in Next static by default, but you can mark them as dynamic. For that, you just have to look into the Next specific documentation. For this presentation today, we just wanted to keep it as high level and specific to server components and less about Next though.
Can I pass parameters to the server action from the client?
Yes, I just showed it really quickly in the end. You might have noticed that I passed on the ID as a parameter to the function. And what's also cool is you can not only pass to the function, data to the function, but it can also return data that you can just use for parsing whether the operation was successful, for example, or not.
But you're running in a different context, so you cannot use like hosted parameters or something like that, as you're not in the same scope, right?
Yeah, but you can just since it behaves like a normal function, you can just throw into the function everything that you want and deal with that.
Are the endpoints protected from direct calls? I think it goes somewhat in the direction of what we had earlier with can someone else call my API?
No, they are not protected, so you'd have to deal with authentication, whatever method you use, be it checking JWTs and cookies manually or using specific features like middleware in Next. So if there's something that needs to be protected, you have to still do that.
Cool. Cross-origin is also a thing that goes in that. Just
what's really cool. Thank you for mentioning that, by the way. If you fetch data in server components, you don't have CORS problems because that's not running on the client.
Oh yeah, that's true. That's cool. But who deals with CORS problems? You just do a wildcard and you're good. Yeah. Don't do this at home. Don't do this at home. Does revalidate path render the whole page new?
It will be completely re-rendered on the server. The entire payload gets sent to the client, and the client just picks what has changed because the server cannot know what the client has and cannot selectively re-render things.
That makes sense. Is there anything to watch out? Probably yes. If we like to authorize users, version for the public that doesn't have the card mutation and admin version, or is all the same as in the past?
It looks a bit different, but everything is the same. You would either in your server actions just check whether the user is authorized and return early if it isn't, or already use middleware that runs before any request to prevent any unauthorized requests.
Cool. It's a little bit of a personal question, but what backend stack do you think goes well with Next.js to leverage the server components rendering even more?
Well, Next itself is a full stack framework.
True.
For many, many, many cases, it's sufficient enough.
Oh.
And I'm slightly a bit biased because I've used it for most of my time. I like it.
Sounds good. Okay. Let's have one more question, even though I think we covered all.
Cool.
I don't see any more questions. So we covered all more or less on time, if you consider about 30 minutes.
Then I have one final thing that I want to show. If you can quickly switch to my screen. So in case you want to know much more, here's the next page, or the next website. And in the docs, even though this is specific to Next, there is one chapter called React Essentials, which is very, very specific to server components and not tied to Next itself, which goes over a lot of the things I've mentioned and shown today. Has even some fancy graphics to show how to actually compose things here and there.
Cool.
So my suggestion is whenever you have the time, check this chapter out in particular. It helps a lot to build your new mental model when interacting with server components and what changes whenever working with those.
Cool. Thanks for sharing that. Appreciate that. And let me try my screen magic again to get my slides up to wrap things up. Easy. Did you see that? Easy peasy.
Oh, awesome.
So if you want more information, go check out Twitter. We will publish the recording of this and soon on YouTube. So go make sure to check that out. And if you want to be notified about videos like that and things like that we have planned, go make sure to hit that bell. It should be like somewhere down there. So thanks a lot for attending. Really appreciate that. And thank you, Christian, for sharing all those things with me. I feel like I know a little bit more about React Server Components now. So thank you again. Appreciate it.
You're welcome.
Bye, everyone.
Bye.